Welcome back to part 2. As you remember from yesterday, we did a thorough cleaning job on the float switch, removing all the lime deposits, as well as the heating chamber. Then we replaced all the components on the unit and reinstalled it in the house. During the testing procedure, we determined that the unit still wasn't functioning properly and that it needed to be removed again for further investigation and repair. Before we removed the unit, we made note of the conditions that the unit was expressing during testing, and here they are. Okay, so here we are back on the bench. Didn't work yesterday. So I'm thinking that the float switch was either not cleaned well enough, which I kind of doubt, or it's defective, or there are some other reasons why it's not working. One could be a temperature control fault that disguises itself as a float switch problem, and we'll get into that a little bit more later when we look at the diagrams that I found. But right now I'm going to pull the side cover off and get a look at the float switch itself from the outside. I'm not going to take the top cover and the other float out yet. I may do that a little later, but right now I'm just going to look at that float switch on the outside of the tank and see what I need to do to possibly remove that. Okay, with the side cover removed where the electronics are, I can see the float switch. I'm just going to come in on it slowly here. And that's what I'm going to be looking at here. What I'm going to do is first of all take the wires loose and see if I can get a continuity test on that switch. I don't know if that's possible on this switch. I'm not really sure about how this switch works. It may have some type of a magnetic switch in it, is what I suspect. But I may be able to get continuity and then an open, and that's what I'm going to try for right now. Okay, the two leads from the float switch are free, and now I'm going to see if I've got continuity in the upright position, and if I do, then I'll flip it over and see if I maintain continuity when the switch should be closed, or vice versa. I'm not sure which is the condition inside, but if we get a difference with the unit sitting here and then flipped over, I'm gonna think that that switch is okay, period. Okay, with the two probes attached to the leads off of the float switch, I'm reading a open condition on my meter, which is right over here. OL. I'm going to flip the unit over with the same leads attached right the way they are and see if I get a closed situation. If I do, I'm going to think that that switch is okay and that there's something else wrong with it. And here again with the leads attached to the float switch leads and then to the multimeter, I have what I suspected, which is a resistance reading of about 1.5 ohms at most, which tells me that that switch is functioning, is not the problem. And I think I know what is, and we're going to look at that next. This is a component layout diagram of that unit. and that's what we're going to be looking at now. Hopefully this is clear enough on your monitor that you can follow along with me here. I'd like to start by looking at the float switch, which on this diagram is described as the water level switch. If you notice, the water level switch and the thermal switch are wired in series. One lead from the water level switch going to J5 on the printed circuit board, and then one lead from the thermal switch connected to J4. That would tell me that any problem that would occur in either one of those two units would be expressed as an error 5 on the controller. Since we know that the water level switch, or the float switch, is working, that would lead us to suspect that the thermal switch is defective. So the next thing we'll want to do is test that thermal switch to see if it's functioning correctly. And that will be the subject of part 3 of this video series.